No, that's not bad. That's not good.
We actually just
No, we're not.
I have a question for you.
What? Go.
When are you going to put grades for anything?
What do you mean?
You guys told you guys did. Well, I know I haven't taken the first two yet, but like the warm-up that I was going for the triangle worksheet that you counted missing, and
Have you checked the grades since this morning? Because I plugged in stuff yesterday. Check that.
it's running.
Oh, like, are you asking about missing stuff? Is that what you're asking about?
Yeah.
Yeah.
Just grades and buttons.
That stuff gets to the bottom of the bin because I have to grade the correct stuff first. But yeah, I will.
Mr. McMahon.
Oh, that's weird.
Yeah.
There's this guy in our group chat named Sean, and he keeps on trying to push like Trump shit on us, except he doesn't use proper grammar. Like, it's like caveman talk, and I'm like, dude, yeah. And I'm like, yeah. And I'm like, dude, if you want to make a legitimate point, because we're all like discussing this civilly. He's like, ooh, booga booga Donald Trump.
Yeah.
It's like,
So,
saying.
Give me my launch card back.
Quiz 4 is due. We're putting it in Friday because we have a grade.
these two, I turned both of them because I was going to. So I put absent on top and I turned it in.
No more.
It's in the bin back there?
Yeah.
Okay,
And then
so I was
so
absent.
is the triangle.
So that'll be in. I was absent. All I brought home was this, which is all the late work from last week. So I'll get those bins fixed. They get graded.
Last week.
You did. You did. I know. Late work from last week. Late work. That's on time because it was due last week. You're okay.
I don't know.
Is it a 0 or is it a star?
I'm not saying anything.
Because it might be a star, and if it's a star, it doesn't even count against you.
Can you snap?
I don't know.
It's very cool.
Oh.
I don't know. I'll take a look at it. But either way, it'll be okay.
D minus in this class.
You what?
I have a D minus in this class.
Yeah, I know that. That's not good. That's because you're quizzing.
11% in your class. He wants to know what's up.
No, it doesn't have a star, it has a check.
He
It
gave me
has a
1,000
minute.
on one of the workouts.
Oh my god.
Why would you say anything?
Because I want to know what my actual rate is.
Sorry, I might have done that just
I
now.
would have said
Yeah,
that.
you put one in as 1,000 instead of 100.
Alright, thank you for telling me that.
If you only
have
111% with 1,000 points put in.
No, you put in 1,000 points for one of the ones. I don't know why is that.
Alright, Justice, I fixed it. I'm sorry.
No way, she's just 111%.
Alright, so let's get started. Before we get into the proof today, the proof of Ceva's theorem, before we get into that, you need to understand the lemmas from 2 days ago. Have a seat. You were absent. Let me get your thing.
Why are we moving on when I failed 3 tests?
Me too.
Because that's how it be, guys.
Let me get catch up.
I thought we were grading today.
No, if anybody would read the Google Class thing, it said Friday.
Do we ever test Friday?
No, sit down, guys. So, I explained it all on Google Classroom. If you have questions, go there first. Wonderful, neither was I. So, yeah, why would you tell anybody to do that? It's rude.
That's not okay.
Alright, so here's the deal. You need to understand these lemmas. I proved them on Monday. So I'm just going to draw your attention to the fact that they are true. So if we have 3 things that are proportional, right, then we're allowed to mess with the math and make them look like this. So you take the first 2 and subtract them from each other, and you get E over F. Now this is not how we normally subtract fractions, right? Which is why we had to prove it. It's kind of a weird thing, but it works if all the fractions are equal to begin with, okay? So there's that. And then the other lemma you need to know about is that triangles are proportional to their heights and their bases. So namely that this triangle here and this triangle here, since they have the same height, Flopper, since these 2 triangles have the same height, and they do, because they're in the same triangle, right? So they have the same height. So their areas will be proportional to their bases. So the area of this triangle is proportional to C, and the area of this triangle is proportional to D, okay? These guys go together, and it's because their heights are the same, okay? So here's the other thing you needed to know. It was about Cevians. Remember, we talked about Cevians being anything that's from a vertex to the opposite side of a triangle. Let's see if I can find a copy of this. Yeah, there we go. So again, we said area of the triangles, right? That's what the area would be. That's the area of this triangle. Since they have the same height, those heights divide, and we get 1. Half divided by half is 1. And so if the heights are the same, then the areas of the triangles are proportional to their bases. It will when we have 2 triangles that have the same height, and in this case they would be because they're in the same big triangle. Right? Right, exactly, because they make up the big one. But if I gave you two random triangles, they might not have the same height. Does that make sense?
Oh, but
Right.
if it's like all in one triangle.
Yeah, definitely, because they'll all be at the same height. They all come to the same point, right? That's the beauty of having two triangles in one. They'll always be, these two will always have the same height.
Let's go.
Okay? And so they'll be proportional to their bases. Then we talked about Cevians, which are a line that goes from a vertex to the opposite side. Angle bisector is an example of a Cevian. A median is an example. An orthogonal. Perpendicular bisector can be, but most of the time it won't be because it goes off and just heads off in whatever direction it wants. If we get lucky and it's the perfect kind of triangle, like if that happened to be a perpendicular bisector, then it would be a Cevian, but most of the time they're not, right? They just kind of go off at their own random thing. So this is going to help us prove that these different things are concurrent, that they do all intersect at one point. So Ceva's theorem says if we have three Cevians, and we do, that are concurrent, all intersect at one point, then the relationship between the bases here times the relationship between these bases times the relationship of these bases will equal 1. And we're going to prove that that's true today, okay? We're going to use the converse of that to prove things concurrent, and that's going to prove that angle bisectors always intersect at one point, that medians always intersect at one point. Basically, it proves the existence of those centers, right? The in-center, circumcenter, metacenter, etc. Right? Remember, we moved around in GeoGebra and to see if the triangle would change it so they wouldn't intersect. Right? And we just said, look, they're fine, they do. They always intersect. But now we're going to prove it, okay? So this is going to be a lot of alphabet soup, okay? But it's not that hard because it's a lot of same dumb logic, okay? So I would encourage you to watch and not write. This means absolutely nothing to you right now, right? It's all just complete alphabet soup garbage. So don't write it down and not color. Just watch the first time, okay? It'll be all right. I had Zayden and Cheyenne teach my 3rd and 4th hour classes for me because I had meetings. So they TA'd for me and they did a pretty good job teaching that.
They taught this?
Yes.
Who? How?
Well, Cheyenne was here for 1st hour, and so I taught it to Cheyenne, and then Cheyenne taught 3rd hour and taught Zayden, and Zayden taught 4th hour. So it's not bad if you try to pay attention instead of writing stuff down. Okay? It's doable.
We have time to rewrite out.
Yeah. So here's the idea. We have a triangle with 3 different Cevians and they're concurrent. So that's what this says, right? If this is true, then prove that. Prove that these bases relationship times these bases relationships times these bases relationships will be 1. So here's what I'm going to do. First off, I'm going to note that these 2 big triangles, triangle ADC and triangle BDC. Do you see those 2 triangles, the left side triangle and the big side, or the big right side triangle? They have the same height, don't they? Right? Height of this triangle is there, height of this triangle is there, right? So if they have the same height, that means their areas are proportional to their bases, right? Does everybody see that? Lainey, are you with me on that? I'm going to write it and see if you understand what I'm saying. So the area, yes I can. I know it's hard to see the diagram, but I'll have to zoom out eventually, so reference your own. But I'm using markers so you can read that even when I'm zoomed out.
Is this?
Page 4.
You don't have to write the thing.
Huh?
You don't have to write it.
Not right now. I'll let you write at the end. So area of this triangle, that's triangle ADC. I'm going to do ADC. Proportional to this triangle, BCD. And we know from our second lemma that this is how they should relate. They should relate to their bases. So the base of the blue triangle, that's this triangle right here. I'm not going to color it in because we're going to have a lot of coloring to do. What's the base of this triangle? Little a, right? We could use AD for that as well. I'm using little letters because we already have enough letters going on right now, right? And then BCD, what's the base of BCD? Little b, right? That's from our lemma, right? We know that to be true. If triangles have the same height, then their areas are proportional to their bases. Cool?
Does that say A?
That?
No, on the other on the.
That's an A, yes. So this means area of the triangle. That's what that means, okay? So area of triangle ADC, the area, and this guy's area. Cool?
I have a question.
Yeah.
So when it's asking us to like, prove that all of that equals 1,
Mm-hmm.
is 1 being the whole triangle, or?
So what we're going to do is we're going to find out.
Them all into one?
We're going to find out what A over B equals and what C over D equals and what E over F equals. And then we're going to multiply them together and see what happens. And when we mess with math, it'll end up being 1. Okay? So right now I'm trying to figure out what A over B equals, and it equals this. Okay? Did you see how I got that? Area of this triangle is? Okay, so now I know what A over B equals. So when I write A over B times C over D times C over E over F, I can substitute these guys in, and things will cancel. Okay? You'll see it. Okay? But the reason I'm doing this is I'm trying to find what A over B equals, and I'm trying to find what C over D equals, etc. Now, it turns out, if I were to do this for all of A and B and C and D and E and F, I wouldn't get things that cancel, because these triangles don't overlap. So what I'm going to do is I'm going to do something else that's kind of clever. What other triangles that share this height also have base A and B? Tell me the triangles. AGD and GBD. These two triangles down here, right? So by the same logic, they should also be proportional to A. So I'm going to write, let's do lighter blue because it's kind of related. Area of triangle AGD, or we'll do ADG for alphabetical order, should be proportional to A. And then let's use a lighter orange. Area of triangle, this guy down here, right? BDG. Also has base B. Oops, I'll use the same color. Okay. So far so good, right? Big triangle here has base A, big triangle there has base B. Little triangle, since they have the same height, will also go with A and B. Right? Okay. So here's my logic. This equals A over B, and this equals A over B. So don't these equal each other?
Yes.
So another way to write that is I can write area of one triangle, area of another triangle, area of the second set equals this. Right? Yes. They all equal each other is what I'm saying. Are we cool with that? This, and this, they're all equal to each other. We cool? Now notice, if they're all equaling each other, then we've got something cool going on here. And I'll show you. We've got this. 3 things that all equal each other, right? So we should be able to take the first 2 and subtract them and get the third. Okay? So I'm going to take these 2.
How do we subtract letters and new numbers?
So these are just the areas of the triangles. That's it. We don't know what the area is, but we know if we were to, we can use them, right? We can mess around with them. So here's what I'm going to write next. I'm going to say this guy minus this guy over this guy minus this guy equals A over B. Again, taking the first 2, putting together like this, they should equal the third guy.
Wait, say that again, like with the other letters?
So
No, other page.
these 2 being subtracted over these 2 being subtracted should equal A over B.
Okay, which
Okay.
one would go first?
So I'm going to write that one out.
Which
So
one would go first?
I'm going to go with the bigger one first. Again, it doesn't matter which order we do it in. One will get you a negative answer, one will get you a positive answer. That's a bigger triangle, so I'm just going to write that one first. It doesn't matter. So I'm going to say, because of this, I know area of triangle ADC minus the area of the smaller triangle on that same side. And then we've got this guy, area of triangle BCD, and area of triangle BDG. When I subtract those, right, I should get A over B. Now that's really weird, and you wouldn't expect that, which is why we went over that lemma the other day and we proved that it is true, right? If you have 3 things that equal each other, you can take the first 2 and set them up like this, and it'll equal the third. So I took these guys and put them in here. Do you see it now? And it equals the third. Okay. Again, seeing it is the hard part. So that's true. And again, why are we doing this? Because I'm trying to figure out what A and B are. And here's where the magic comes in. What is this triangle here minus this triangle here? I'll show you again. This triangle, the big triangle, minus this bottom little triangle. What triangle is that? CAG. So check it out. Do you see it? Big triangle minus that bottom part is just this part. You see it? So when I write that, another way of writing that is just saying this guy. Yeah. So this goes with A, right? And this would go with B. Again, big triangle that I would color in dark blue, that's this guy, right? Minus the light blue triangle, this one right here, leaves this left over. Okay? So I'm going to substitute that. Is that okay? You guys see how that's the same thing? So I'm going to use this color. Let's use super light blue. So I'm going to write that area of triangle. Now this guy is triangle ACG. because that's what that is, right? When I subtract them. Over, let's do it for the other side. So big orange triangle is this guy, right? And if I subtract that bottom part, what triangle's left over? Triangle BCG, alphabetical order, but yeah, same thing. So I'm going to write that in like a orangey color. Let's do, it's called BCG. Okay, I just substituted that for this and that for that. And so that should also equal A over B. And this is really what I want. And here's why. Notice that this triangle here and this triangle here are going to overlap when I do this for my other sets. So, see how this went with A, right? And this went with B? Can I do that for this triangle? What would this triangle's base be? Oops, try again. I want a single letter. Base doesn't always have to be on the bottom. It's C. Do you see it? It's on its side. So that's the base. What's the base of this triangle? D, right? And then I do the same crap, right? Subtract the bottom parts, and I get this triangle goes with D, and this triangle goes with C. So I proved earlier that this triangle goes with A, and
Are you going all the way, so, for like the one whose base is C, but are you going all the way to E? Like A and B? Or
so what I said was that this big triangle right here goes with C, right?
Okay.
And this bottom triangle goes with C. So if I subtract their areas, that means this guy goes with C. Okay?
Sure.
I'll show it again up here. This big triangle goes with D, right? Has a base of D.
Okay.
And this small triangle has a base of D. So when I take the big triangle minus this little triangle, what's left over is this triangle. And so it must go with D. Now I'm going to do this for all the sets. I'll do it for E, little e, right? There's a big triangle here that uses E as its base. There's a little triangle. When I subtract them, I get this. So this must go with E. Same thing over here. This must go with F. Right? So this triangle goes with A. We proved that just now, right? That triangle goes with A. But notice that it also goes with D. Right? So now we have overlap. So now that I know that this equals A over B, I can do that for C over D and everything else. And when I put them together, there'll be overlap. Huh?
Because, and then like things equal each other and then equal.
More or less, yeah. You'll see what happens. Don't try to get ahead of the game in that regard. I just want you to see what triangles go with what. Do we see why this triangle here goes with A? I'll color that in. Do we see why this triangle here goes with A?
Is it because it's inside a triangle and
Yeah.
CD?
If you
Yeah.
subtract that,
A is
So-
the base of
So we
CD.
said earlier that this triangle, right, goes with A,
Yeah.
right, because it has base A. And the orange triangle goes with base B,
Yeah.
right? Now, again, if they have the same height, we're allowed to say that, okay? Then we said, look, this triangle also goes with A. And this triangle also goes with B. Notice how those two triangles have the same height, right? So they could go with A and B. Now we know from our lemma that if this equals that and that equals that, we're allowed to write this. It's kind of weird that you can just subtract these two and get this, but it's true. We proved that the other day, okay? Everybody with me there? And then I said, what is big triangle minus this triangle? Well, it's this guy. And what is big orange triangle minus this triangle? Well, it's this guy, right? So these two must go with A and B. You with me?
because they make up the median. Because they're subtracted by.
Right, yeah, yeah.
triangle.
Big minus the small leaves the medium, right? Big minus the small leaves the medium, so they must also go with A and B.
What do you mean big minus? Oh, okay.
Right? Now I'm going to do this same dumb logic with the other triangles. So here, let me grab a new one of these and I'll color it differently. So same dumb logic. Okay, same triangle.
But we're trying to get C this time.
Yeah, we're going to get C and D this time. Notice that this triangle and this triangle, let me get my red out, are the same height. Right? They're the same height.
Can you turn it outside?
Yeah, does that help? Right, those two have the same height. And they have base C and D, so they're proportional. Then I can do the same logic as before. This triangle here and this triangle here have the same height, it also go with C, right? C and D. So if I subtract those, what's left over must go with C and D. Well, what is left over? This triangle and this triangle. Let's use bright pink. And they must go with C and D. Cool. I'm going to do this for all of the triangles. Okay?
And then you have to write it out.
So, yep, it'll be okay. It'll be alphabet soup, but the logic is not bad if you see it. So, let's just look at these triangles. Not the big triangle and not the little triangle, but the medium triangle. What's the medium triangle that goes with little a? What triangle is that?
AFG or AF, yeah.
A, C, G. This guy, right? This whole thing. Yeah, medium.
what's the
So,
big one?
so big is this,
The entire,
right? This half, right?
yeah.
Goes with A. This little guy goes with A.
Yeah.
What's left over should go with A, right? So I'm asking about the leftover, the medium, okay? And there's a lot of triangles here, it's Triangle City, but this guy goes with A, right? So that goes with A. What goes with B?
EBG.
Yeah, B, C, G, this triangle here. You're stopping early. Keep going. It's this whole thing.
Wouldn't every triangle on that side go with B?
No. I don't have time to explain now, but no. So that goes with it, goes with B. All right, what goes with C? A lot of triangles, but what one am I most interested in?
BGA.
B, G, A. This triangle right here.
Alright.
Goes with C.
You win.
And then what goes with D?
C. BG.
C, G, A. This triangle. What goes with E?
I quit. BFC.
B, C, G.
Oh,
Right?
why?
There's no way, that's not even part of the triangle.
Oh my God. All right, here we
I
go.
quit, Mr. Mayor.
Let me do it one more time. It's okay. Seeing it's the hard part, Lainey.
So, you're basically taking like A and B and like subtracting those triangles.
Essentially, yeah. So guys, notice that this triangle, we're going to spend a lot of time on this because once you see it, it's like, oh, of course. But until you see it, it's hard, okay? So don't be upset if you don't see it at first. These two triangles have the same height, true or false? True. Which means their areas should be proportional to their bases, right? So those go with A and B. Also, these triangles have the same height, don't they?
Yeah.
So their areas should be proportional to A and B. So they all equal each other, right? So that means I should be able to take big blue minus little blue and get A, and big red minus pink and get B. Remember that? I'm showing you the same thing. Don't worry about this, okay? It's the same diagram. And that's our first lemma. Remember that, where we have the A over B equals C over D equals D over F, right? We were able to do that weird algebra thing, right? So, but what is big blue triangle minus little blue triangle? It's this one, right? AGC. So this must also go with A. And then the same dumb logic over here. Let's choose a different color. Let's do yellow. Big red minus little pink, right? This must also go with B. And that's what I wrote.
So why couldn't you do the big red minus the...
Okay? So that's all that meant. I used different colors, but that's all it meant. We good? Now I'm going to do that with all the other triangles. So here's another diagram. Same diagram. We're going to color them in. All right. So I'm going to keep it this direction so the letters are the right way. So big pink triangle here, doesn't that have the same height as this triangle here?
Yes.
Yes, so their area should be proportional to their bases, C and D. Okay? Yes?
Well, the quiz over like this be next Friday?
Yes. Mhm. Yeah. And then this and this, they both have the same height too, don't they? So they should go with C and D. So big red minus maroon, big pink minus little pink, right? Gets us these guys. So that must go with D. And that must go with C. We cool? Now notice Didn't we already color in that triangle in our other diagram? We did. So now we have some overlap to talk about, okay? That's why I'm doing this, to get those triangles together, okay? Same thing again with E and F. So my logic is this big triangle is the same height as this big triangle. You guys see it? Same height, so they go with E and F. This guy and this guy are the same height, so they go with E and F. And if I subtract them, what's left over should go with E and F. So that's going to go with E, and that's going to go with F. And those are the triangles I'm interested in getting with E and F. You guys see that pattern now? You seeing that? More or less? Katie, are you with me on this?
So did you just answer what it says to prove?
So, hold on. So I proved that these two triangles go with A and B. You cool with that?
Yeah.
All right. I'm going to do that for the same. So by the same dumb logic, I'm going to write the rest of the triangles out. So here's what I'm going to do. So let's look at this one, because I'm running out of time. That's the first half of the problem that we just did. I used different colors, okay? I said by same dumb logic, these guys go together, right? They get C over D. What is this? It's this, trust me. Okay? When you subtract those triangles, you get that leftover triangle, right? That's what they are. We cool with that? So I'm up to here. A lot of writing, but there it is. Now I know what A over B and C over D and E over A equal. And if you notice, look, A over ACG, ACG, ABG, ABG, BCG, BCG. So when I multiply A over B and C over D and E over F, I set them equal to all this stuff multiplied, right?
Yeah.
And what happens? A over ACG divided by ACG, 1. Anything divided by itself is 1. ABG divided by ABG, 1. BCG, 1. And what's 1 times 1 times 1? 1. And that's it. Okay? It's a lot of writing, but if you see the triangles, you'll be okay. Again, yes, go ahead. Big triangles share A and B, right? Little triangles have A and B. So I can subtract them and get an A and B. And when I subtract them, what triangle's left over? These guys. Yep. And I do that for all three pairs. The AB pair, the CD pair, and the EF pair.
This is algebra.
And then I multiply, yep. Good news and bad news. Bad news is this is algebra. Good news is that, notice we didn't write bilinear pair theorem. We didn't write by vertical angles. We didn't write anything, did we? You don't have to, because it's all by algebra. Okay? So to prove Ceva's theorem, we do algebra. And once you see the pattern will be the same for any triangle you draw. Okay?
Yeah.
Is it something that you're not going to be 100% with right now? Yes, because it is new and it's weird. But is it something that's so difficult you're never going to get it? It won't be. And if you feel like it is, that's because you haven't seen the triangles yet. Please, give me some time to show you, okay? Tomorrow what we're going to do is we're going to prove the converse of that. Notice the proof says if they're concurrent, then we get this. So the converse is going to say, if this is true, then they're concurrent. And that's what's going to allow us to prove that angle bisectors are always concurrent, that medians are always concurrent, et cetera, et cetera. Okay? That's the big thing. So thanks for hanging in there today. I know it's kind of alphabet soup and it's a lot of writing. If you want, you can copy down this stuff. Or you can take a picture. Yeah. Yes. Okay. Like and subscribe, leave a comment.
Hey, what's up with the guitar?
Oh yeah, the humidity got, like the weather changed a lot and it exploded. What? What? My merch drop over my YouTube channel. Here's some hot new shirts. Practice. I won't say. I didn't say it. Your words, not mine. What?
Explain it to Lori.
Awesome. Explain what to Lori. No, the humidity changed and it busted. I know it's good. This summer I'll be making short videos to upload to my channel that'll go over like small topics. Maybe. Seriously. Yeah, I know.
Thank you for the children.
Right, go away.
Sounds good.